blueprinting your internals, exploiting internal network vulnerabilities by browsing using BeEF. So to give you a bit of an intro about both of us. I work at Pure Hacking and the CTO. Run Project shellcode.com, so if you want to have a couple of old but good shellcode demos, tutorials and stuff, it's pretty good. If you want to see a whole bunch of spam in an unmaintained forum, that's also a good place to go. I also run the Shellcode Lab training at Black Hat USA, which has been pretty successful over the last couple of years. Had about 52 guys rock up to it this year, which is pretty good. And also one of the authors of Hacking Exposed Linux. And you can do your own intro.
Hey guys, well now I'm working in Spider Labs. I'm the lead core developer of BeEF. There are a lot of BeEF guys over there. Raise your hand. All back. Where is Wade? He's still drunk, eh? Motherfucker. And well, I like application security research, and I'm a big fan of Ruby, JavaScript, and OpenBSD. That's all.
Awesome. All right, so to give you an overview of sort of what we're talking about today, basically we're going to look at the current situation of basically browser attacks and gaining, a remote foothold on your internal network. Michele is going to be talking about BeEF and inter-protocol exploitation, sort of taking that to the next step. I'll be talking about the BeEF bind shellcode, which we've just created, and Michele will talk about the integration of that shellcode into BeEF and how you deliver that to remotely compromise an internal network through a web browser. And then we've got a couple of demos in there as well, so fingers crossed. So basically at the moment, when you're doing things like your phishing gigs, or you might have really malicious cross-site scripting that is an exploit on the other side, you're basically looking at exploiting the browser or the browser plugins or some sort of client-side code that's you're basically restricted to the workstation. So you sort of hit a number of different issues with that sort of technique, and with the browsers getting more advanced these days, and you're finding a lot of pretty intelligent sandboxing and things like that, even though they seem to get bypassed all the time. It's very limiting in what you can actually do with them, as well as only having a pretty low success rate, unless you've got a 0 day. And a lot of us don't have 100, 200 grand or whatever they want to charge for 0 days, or the good ones anyways. So you've got other things where you've got to rely on the fact that your victim's machine or the web browser or their client-side software isn't patched. You don't have the 100K. And also, you don't necessarily know upfront what their browser is that they're using, or the specific version of their browser, if it's not leaking that sort of information in the user agent and all that sort of stuff. Then you've got things like your plugin vulnerabilities. How reliable are those exploits as well? I've hit, I don't know about you guys, but I've hit times in the past where I've actually had clients where I'm trying to exploit client-side vulnerabilities where they've had like IE6 and like really old Adobe Reader, and the fact that those two versions didn't actually work together with the exploit, basically meant that they weren't able to be compromised through that exploit, and it failed. Whereas, if they were using a more modern version of a web browser, it would have actually worked. So there's all these little things that basically start cutting down your success rate of client-side exploitation, and you basically don't get your foothold on the internal network. And then you've got, we're not talking about things like the, your malicious Java applet that you can fire up through Metasploit and all that sort of stuff. But they typically, rely on some sort of user interaction to get that running on their system. Okay, so does anyone not know what cross-site scripting is? All right, get out. So, according to OWASP, are there any OWASP guys in here? Come on. Also get out. According to OWASP, you know, the alert box is the #2 most dangerous attack in the world. And, you know, we've all seen them 1,000 times, but, you know, we're going to take it to the next level and do an alert 2. No, seriously, with Burp, we're basically, you can talk a bit more about that, but taking it to the next level and actually using cross-site scripting, one, not to just hijack your browser, but also to compromise your entire internal network. So,
I'm curious, if a question for the OWASP guy, why did you classify injection and then XSS as a different, that like is not injection, why is injection in the DOM? It's quite fun, but anyway.
That's all right, I'm sort of ahead of schedule.
Terminology works.
All right, so basically we've got all these internal server vulnerabilities sitting there lonely and bored. You know, sort of like, if you think about it, like you have a room full of bored and lonely IT security guys, and really all they're waiting for is this stripper to come bursting through that back door. So this presentation is about us bringing you the stripper. Okay, so on that note, I'll hand it over.
So this is the idea flow. Basically, Wade, that again should be here, is not here. Okay, he was drinking with us yesterday. So he said, my inter-protocol exploitation research was cool, we should research further. So Ty then came with this awesome shellcode that he will describe in a moment. And then I said, okay, let's put everything together, let's do some research and let's see what we can do in 2012. Because his research was originally from 2007, I guess, 2008. So here comes BeEF. Who knows already what BeEF is? No, not a lot, okay. So Wade Alcorn created BeEF in 2005, 2006 basically as a framework. Basically, it's a web application that sells a JavaScript file, and when this JavaScript file is executed in a victim browser, an asynchronous communication channel is created, and you can control the DOM, so the document object model of the page which is running the JavaScript file, and with all the same origin policy limitation, you can do a lot of nasty things. We have modules for social engineering attacks, internal network exploitation, Metasploit integration, and generally everything you might need to fuck up a browser. And so the idea is basically that every browser, as Ty said, is a different kind of browser running on a different operating system, on a different patch set, and different plugins. So they all have a particular exploitation scenario, which is different. And what you want to do is fingerprint exactly which browser is hooked in BeEF and assess which kind of features you can exploit. So you don't need anymore to show alert 1 in your pen test reports. If you are playing without a written consent, it's up to you. There are people that are using BeEF for bad stuff, like the Jester, anyway. And the point is that through a simple XSS or a phishing page, you can control completely that particular tab, or eventually go further and control the whole browser or even the machine. For example, with Chrome exploitation, if you inject a Chrome malicious extension, you can completely control every tab in the browser, achieve persistence, and yeah, it's better than a normal rootkit, in my opinion. And features like man in the browser, tunneling proxy, which we cannot cover now, but if you look at all my previous presentation or Christian presentation, there are a lot of we covered them all. So we developed a lot of stuff like tunneling proxy, which was an idea from Ferrum Avituna, which basically is using an XSS like a proxy. So what I did in BeEF is I created a server socket in Ruby.
Thanks for turning up, Wade.
What is, okay. Clap for Wade. So with the tunneling proxy, basically you point your browser to the BeEF server, that has basically a Ruby server socket, which is listening and parsing the requests that are coming from your browser. These requests are translated to AJAX requests. They are injected in the victim browser. The victim browser is requesting this data for you, and the data is sent back, and so you can actually run, you can concurrently see what the victim is seeing, so like hijacking his session without actually stealing the cookie, for example. So about interprotocol exploitation. So Wade, as I said, in 2006, 2007, did this awesome research. And why it's called interprotocol exploitation? Because actually you want to send to a protocol, let's say IMAP, data using another protocol. In this case, HTTP. And the nice thing is a lot of protocols like IMAP, IRC, SIP, and probably also a few implementation of SMTP, they are, let's say, tolerant, meaning that if you send crap, they don't send the reset, they don't close the connection, they just keep receiving crap. So if my crap is, for example, an HTTP request, where the HTTP headers are parsed like crap by the IMAP server, but in the HTTP body you have, for example, valid commands like login, pass, and those commands are in fact interpreted and parsed and executed. So the idea was to actually send shellcode. And Wade did the research using HTML forms, and we did it in a different way. And this is, let's say, the evolution of his research. And so all the limitation we had, I really would like to first of all cover the limitation and then cover what is exactly the technique. So the first limitation. Same origin policy, cross-domain restriction. Now the point is that depending, so all the browsers are different, right? In BeEF we support Opera, Safari, Chrome, Firefox, Internet Explorer, and some mobile browsers as well. Every browser is different, so how the same origin policy is implemented in Firefox, for example, is completely different from Internet Explorer. In Internet Explorer you cannot send cross-domain post request, while in Firefox you can send cross-domain data, and the data is arriving, in fact, to the server, but you cannot read the response if the domain is different. But it's still enough to send blindly the data to compromise something. And this is a requirement that is really helpful for us. Then, port banning. Again, every browser is interpreting in a different way, but in Firefox and WebKit, you cannot send HTTP requests to ports like 22, 25, 143. If you go in about config in Firefox, you can override this configuration. And the nice thing is actually that if you install a Firefox extension, the Firefox extension has complete control over the Firefox browser. So you can override the port banning, disabling all, like saying, okay, I can send the HTTP packet to 143. Then you can also override the user agent, and as we will see later, it's quite helpful because we will have more space for our shellcode. And you can do really, like, you can enable by default Java, so you can even go further and compromise on the next step the browser with the Java applet. And another limitation was the header size. So every browser generates, when you create an AJAX request, the size of the headers is even bigger than a normal request. And most of the HTTP request headers cannot be overwritten in JavaScript for security reasons, like content type, because you can then do HTTP response splitting, for example. No content length, sorry. But there are a few of them that we can override. So the content type, the accept language, and we can save some space. The point is that when you send the crap I said before to the service, to IMAP, actually you are sending all those HTTP headers as well, obviously. So those HTTP headers are being interpreted as bad commands, of course, but they are also there in the memory and then there will be for sure your shellcode. So obviously, if for example you had like 700 bytes of space for your shellcode, you need to remove 400 bytes at least for the headers. And we will see later that saving size here is quite important, just to have the possibility to port more exploits with this technique. And another limitation was the content type setting. So in the original research, we had used multi-part form data to save space, and also in order to be more reliable, we used content type to explain, which is something that basically saying the request will be just explained, don't worry. And after exploitation, obviously, we are not sending like a reverse interpreter shell. We are sending the new shell that the new shellcode that Ty developed, which is the following.
Okay. All right. So yeah, like Michele said, Wade basically came to me and said, you know, I basically want to extend BeEF so that the web browser can actually start communicating with internal machines, as well as compromise those machines and actually from the browser communicate with the backdoor. To which point I said, you're going to need some shellcode. So basically I then went and created what we now call the BeEF bind shellcode, where it's basically a staged loading shellcode to keep the initial request as small as possible. So things like just so that you can fit it in as many exploits as you possibly can, as well as the fact that because, as Michele was saying, that the HTTP headers actually can take up some of the buffer within the exploit, and actually you may have very limited size to actually work with. So we made it as small as I could, 299 bytes, which is typically pretty good for shellcode, especially with a bit of logic around it, like implementing a web server, which is basically what it does. And then it sets up a port, downloads a second stage, or the final stage, and then executes that, and that's actually the web server that starts listening and proxies traffic through to a command prompt. So by default, it sets up a listening port on port 4444 to accept an HTTP post request from the browser. So at this point, we're already assuming that, you know, your HR lady has clicked on, you know, some link saying, you know, your portal's been upgraded. The web browser's been hooked with BeEF, and then BeEF's basically sent the exploit, it's compromised the system, set up port 4444, which is basically just very similar to just a bind port, the initial stager. And then you send the final stage through, which basically in a post request, that gets downloaded by the stager, gets fired up, sets up a web server, which understands basic HTTP where it can now accept commands being sent to it from the web browser. It'll parse out those commands, you know, sort of ignoring all the HTTP headers and things, and basically proxy that through to a command prompt, where you can, you know, then read the output, send the output back in HTTP responses, where BeEF basically grabs that, proxies it back to the remote attacker in wherever you want to be. So the other thing that we came up against to begin with was that the same origin policy, where, you know, we've basically forced your 90-year-old HR lady to click on a link. She's gone to, you know, some arbitrary website, and your web browser is restricting. You can send requests to internal machines, but you can't actually receive the responses, and that's a problem when you're sending commands. You actually want to get the output, right? So what we ended up doing was, because I actually control the web server, you know, the web server is actually we can do whatever we want. So when we send a response, we actually send the access control allow origin and set it to star, which basically disables the same origin policy for that site in the web browser. And that basically means that you can just proxy data back and forth freely without any issues. Also created a Metasploit payload module to do this. So, you know, you can use all the Metasploit encoding and dynamically change the port and all that sort of stuff. So even though the screenshot says webbind, which was its original name, it's actually BeEF_bind. So I'll give you a quick demo just to show you how the background sort of communications between Burp Suite and the stage actually work. Okay.
What the fuck? Okay.
Told you not to pause the VM.
No, it's not paused. That's a funny thing. Oh shit. Some issues here. Let's try. Let's try to restart it. 1 second.
Do you want to go on with yours whilst it restarts?
Hmm?
Do you want to go on with your
With my part?
the presentation?
Yeah.
And then we'll come back to it.
Come on, porco dio. Let's see if it's restarting. Okay.
Coloured spinning wheel of death.
Yeah. Okay, so while the machine is rebooting, so the delivery of the shellcode in BeEF was quite tricky. It took me some time to do it, and so obviously shellcode is binary data, and the point is that right now this technique is working only on Firefox, latest version. It should work also in WebKit, so Chrome and Safari, but honestly I still need more time to test it, and it should also work probably in Internet Explorer with some Visual Basic script magic, but I don't know. I have to research it. By the way, in Firefox it's working fine, as you will see later in the demo, and so we are using a particular feature that is not W3C compliant, but Firefox implements a send as binary method in the XML HTTP request object. And in those two Firebug screenshots, you can see the first one is the stager, so the first thing that is sent. And as you can see here, you have like in the post body emap commands. So A001 list, then there is the exploit. I changed the exploit that was public with an egg hunter. I had to do that. So this is like the string to search, the shellcode, and the stager. And then the stage is actually the second request that is sent not to the 143 port, but to the port that is supposed to be listening after the stager is running. And you can see here what actually Ty wrote. For WebKit browser that doesn't support send as binary, this code is working. The point is that there are some other bugs that I need to check in my code, so it will probably work soon in WebKit as well. So let's see if the VM is now up and running. Welcome. this is the software that I'm compromising. So in the worst case, so now for the demo of Thai, we are not even using it, but in the worst case, I have a recorded video. Because basically there is like a demo version of 30 days, the full version. So you can just put back the time of the VM, which now seems so slow. Yeah, no SSD, PGP, desktop encryption, that's why. Anyway. Next one. It's completely frozen. Let's see. And the delivery, again, about the delivery and usage from BeEF. Cazzo di computer. Okay. Now, another issue is actually you don't know in advance the size of the HTTP request headers. That's the point. Because you cannot query in advance the XML HTTP request object saying, can you tell me how many bytes the headers will be when I will send the request? So as you cannot know that in advance, and you need to know it in advance in a super reliable way, because an error of 1 byte means that nothing will work. So what I did is actually, before blindly sending the data to a potentially vulnerable service, I'm sending back to BeEF on a different port the same data that I would like to send to the target. Different port, obviously not the same one where the victim is communicating to the hook, because we still need to emulate a cross-domain situation. So the request is sent back to me. I can exactly monitor the size of the headers. Then when sending the final request, obviously the host will change, but I can know that in advance, obviously. So after I know exactly the size of the headers with a bogus body, I can say, okay, the headers are 423 bytes. That's fine. So it means that according to the size of the size for the shellcode that I have, I need to add 25 knobs or whatever else, whatever other crap. And yeah. So if typically like structured exception handling, sorry, my English is crap, exploit in a Gunter non-interpretable exploitation is usually like commands, junk, shellcode, nexe, se, and a Gunter. In this case, it will be slightly different, as you can see with the red text. So HTTP headers first, then commands. So as you can see here, HTTP headers that are not shown here, commands, so 001 list, and then less junk. So in this case, there are null bytes, but they are not shown here in Firebug. And what the fuck? There is something wrong with VMware. Snare had the same issue, so we are probably unlucky. So less junk, and then again shellcode next se, Gunter. So yeah, it was quite tricky. And I really would like to show you the demo with Thai, but this computer is strange. So the view in immunity is basically the following. So I don't know if you can see it. Anyway, you can see here that this is the request when the stager is sent. So in the memory of the IMAP process, because we are targeting an IMAP service, you see post, HTTP, host, all the headers. So the headers are in memory. That's why it's important to monitor exactly the size. And then, as you can see here, commands And then these are the knob sleds that are added because there is still more size. And this is actually the data that need to be measured and monitored, knowing in advance the HTTP header size. So you create X knobs depending on how much size you still have, depending on the headers and on the size of the shellcode. And from a Wireshark view is instead this one. So the first reply from the IMAP server, and so the delivery of the stager. Again, IMAP commands, knobs, and then a Gunter and stager. And then I skip the stage because it's just another post request with just other shellcode here. And then this is actually what is happening when you are sending to the shellcode that is already fully deployed and running a command. So a post request with cmd equal netstat, and then you get the response here. And then, yeah, so let's see now if it's working. Porco Dio, non è possibile. What the fuck? No. So I have the recorded video in case the VMware machine is completely screwed. Bloody Windows.
Shut down VMware maybe. I mean, you can pretty much see what the shellcode's doing anyway from this anyway. So, like Michele was saying, you're basically delivering the exploit, compromise the server. There's a second post request which delivers the final stage, gets loaded up, sets up a web server. On that side, you see that you do a post request command, so you can send whatever Windows commands you like. And then from there, so there's basically a buffer that the shellcode's using. I think it's like 3,000 something bytes. If it's smaller than that, it'll basically just return it like it's shown here in the response. If it's larger than that, you basically send GET requests without any commands or anything, and it'll basically grab the next chunk of the output buffer and then post it back, send it back, and you keep basically sending GET requests until you just receive a reset, which basically tells BeEF that there's no command output left, and at which point BeEF basically grabs all of the output that it's collected, puts it together, and displays it within BeEF. So, I mean, you're not going to see a hell of a lot more than what this screenshot is showing you anyway. So.
This is porco di Torre.
Sorry?
Merda.
So you basically got a browser, you've got your BeEF kit running, and you're then compromising yet another machine, which is running the IMAP service.
Yes, correct. So the question was, you've got your workstation where you've got the web browser that's hooked with BeEF. Are you then compromising a separate machine? And the answer is yes, it's a separate server that can be running whatever tolerant service you like, whether it's IMAP or some SMTP servers, or it could be web servers. And that depends on whether you've got port banning set up, or you can use Michele's Firefox extension, which basically you load up through BeEF. You just say install this plugin, and it basically disables the port banning so that you can start doing more comprehensive port scans across the internal network. At that point, that basically shows up in BeEF, and you say, right, that port over there, send this IMAP exploit across to it, sets up the web-bind shellcode, and then you can start sending commands back and forth. So, I mean, the whole point of sort of doing this was to bypass the need for zero-day exploits, because now that you're no longer restricted to just exploiting, you know, the latest Chrome version or, you know, the latest, you know, Adobe Reader, or, well, not that most people have the latest Adobe Reader running, but, you know, there's no longer that restriction. You can actually start, you know, anyone who does internal pen testing knows that there's hundreds of exploitable vulnerabilities on internal networks. So now you can actually just go to your web browser, scan, find the services, and actually just start sending exploits through those machines. And in this case, I mean, we wanted to set up the shellcode to go back through an already established.
That's why probably this was screwing up the file system, because I had to put back the timers on the Mac, because otherwise VMware was keeping updating it. Sorry for that. I have anyway the recorded video for the last one, so yeah.
So
that means no, I had to shut down VMware. With all the music.
Yeah, you have to install a keygen to exploit machines.
Yeah. So, as you can see, it's super fast. No, okay, let's come back to the slides. I think we need to skip your demo.
Sure.
Because, yeah. Anyway.
That's all right.
Come on.
You want me to keep rambling?
Huh? I hope that the VLC video will not will run properly at least.
Yeah.
Everything looks so, anyway. And
told you should have recorded my demo as well.
I know. Anyway, the demo was basically, the demo from Thai, let's see, was basically the following, but we don't have anything else. So the demo was actually showing that in the VMware Windows XP machine, we were just running the stager, so simulating a situation when the service is already compromised on with the first step, and then the next step is sending the stage with another post request to that bind port created by the shellcode, and then yeah, everything is screwed.
You scroll down.
Yeah. It's also bad. Ridiculous.
So you can see here actually in clear text, these are the web server response headers that are just hard coded in there. So you got HTTP 1.1 200 OK. You got content type, but then you got the access control allow origin star, and that's where it bypasses the same origin policy and lets you communicate back and forth.
And then the second command was, I need to shut down also BAP, I guess.
Yeah. And then that's just the GET request, which basically pulls all the data out of the command output. And then the other one was just sending the command. So you just quit that then.
Yeah. And the third one was a post request only. But now let's play the video properly.
For some reason he downgraded his memory to 256 megs.
Oh look, 6.1 gigabytes used. Strange. Very strange.
Like the monitor or something just killed that. So give you another key planet.
Dai, Cristo. Sorry for that.
they just work, man.
Yeah, I'm planning to go back to FreeBSD like the old days.
I think it's because we were running XP in a VM.
No,
it's been like Windows sort of propagating its stuff through.
It's probably that one. Okay, Barp is closed as well. Okay. So let's finish the slide and then let's have the final video.
Yeah.
All right. And then basically after the stage is fully deployed, we can actually send commands to it, and on the same moment or after 1 month, whatever, when your victim will be hooked again in BeEF, if the service will be not shut down, the bind port will be up and running for ages. And
there's no authentication to it.
yeah, there's no authentication. That's true. No magic packet. And what I did also in BeEF, I added another tab in the admin user interface, adding like a very basic JavaScript terminal. So you can set the target, execute your command, and get commands and get the results from the commands. And so to resume, before showing you the video, the demo, these are the steps. So trick the user to install a Firefox extension. So first of all, you hook a victim browser in BeEF. Then using, for example, the fake flash update, you trick the victim to install the Firefox extension that will disable port banning, will override the user agent, enable Java, and stuff like that. Then you do ping sweep scanning to identify the live hosts in the internal network, JavaScript port scanning. We also have other modules to get the internal network IP through an unsigned Java applet. Or you can just guess, because anyway, usually the subnets are almost every time the same. And after you identify the system with the port that you want to target, in this case 143, you blindly send the stager, and then you send the stage. Port 44 was listening also after the stager was executed, but it will listen definitely after the stage is deployed. And then from this moment, you are allowed to send command, get the results, thanks to the access allow from origin wildcard. And the difference between like a common scenario when you have like a reverse connection back to your server is that in this case, all the traffic is going and coming back from the victim browser. So even if you want to, you don't have any reverse socket connection to your server, and even from a forensics point of view, you will see some traffic that is going directly to the victim browser as JavaScript. So there will be nothing in the file system potentially. Depends, but it will. And also, for example, using WebSocket Secure, because in BeEF we added support for WebSocket and also WebSocket Secure. It will be also quite tricky to analyze if you don't have like an SSL proxy. And finally, the video that will play. Hopefully, I add the video. Porco Dio.
You're not having a crack at a live one?
Let's see. You want to try another? I don't know if we have. Let's first play the video and then we can have a crack at the live one. No.
Yeah.
The better.
Or unless we can wait for the video to load for the next 10 minutes.
The video anyway is basically not edited at all, so. So we are simulating a spare phishing scenario. So etc host, I have bing.com instead of Bing, and so the 06 is the machine when we have our BeEF server with a spare phishing. We start BeEF, and WebSocket is enabled also. That's why it's so speedy. Then. Another thing that I added in BeEF recently is the social engineering extension. So you can clone web pages, add the BeEF hook automatically to it, and then you can send like mass mails to your victims, including HTML emails, not like in set. And so in this case, I already cloned bing.com, and I'm using, as you can see here, use existing true because I modified the cloned page, and I'm serving it to BeEF. So I'm using the RESTful API in BeEF, saying just mount on the root of the BeEF server the Bing page. And there is obviously also the hook in it. So as soon as the victim will go to bing.com, she will be hooked. So here we open the admin user interface of BeEF. And Firefox latest version is our victim. So bing.com, as you can see there, we have, for those of you who doesn't know what BeEF is, as soon as the victim is hooked, we can get a lot of information. So user agent, browser version name. Here below you can see also operating system details. So in case you need to run exploits, you can know the architecture in advance, and a lot of like plugins and features supported. What we want to do now is just double check if everything is working. So like sending a prompt dialog. Okay, we can obviously read the response back. Now, next step is running the ping sweep. Delivering the Firefox extension. Sorry. So Mike Howard, I don't know if the pronunciation of the surname is correct. He's not here anymore, but he will speak in KiwiCon about BeEF. He developed this nice fake flash update. I just changed it a bit, but this is what it's doing. So fake flash update, and when the victim clicks install, you can deliver whatever you want. Originally, yeah, it's fine, thank you. So you can deliver whatever you want. Originally, it was delivering a Chrome extension. Then from Chrome 21, you cannot install any more extensions that are not coming from the Google Chrome store. So we just uploaded them there. And in this case, we want to install a Firefox. As you can see, well, look again. So install, you click everywhere, and there is this Firefox extension. Like you want to allow bing.com, that is actually BeEF, to run the extension. Yeah, sure, allow. Then yeah, there is another call. Allow, restart. Now what you will see is actually a new hooked browser will come here, because I'm overwriting the user agent, as you can see there, and the user agent changed to a smaller size. So this is actually the new hooked browser with yeah, this is hooked again. The hooked browser with the Firefox extension up and running, correctly installed, and in fact this is the pref.js of the Firefox extension. I just took like link target finder, that is like the default Firefox extension in Mozilla, and you can see here that you can overwrite whatever you want. So you can overwrite port banning, you can override the home page, you can override that every time you open a new tab, you open our phishing site, and then you can override the user agent that will be useful for the size of the shellcode, and you can enable Java without any kind of sandboxing. That's quite scary. So now that the port banning is finally disabled, the first thing we want to do is scan 10 IPs of the internal network, just because we are running a demo. So it takes more or less with like 2 seconds, 2 seconds and a half per host to determine if it's alive. And so in this case, 20 hosts, you will see in 10 seconds, yeah, less than 20 seconds, we determine that 135 is alive, right? And then with the port scanner, we want to port scan that specific port on that specific IP, so 143. With one port is pretty fast, otherwise all the default ERMA ports are checked. Port 143 is open. If port banning was not enabled, obviously you couldn't see that port open because you get an error. Now this is the famous bloody VM that was not starting. And as you can see here, 135 is this machine, and there is an IMAP server listening. Now, you send the BeEF bind module, specify, well, you can just leave all these things as they are. The only thing you need to change, except the target host and port, depending what you need, is the BeEF host. So if you are, for example, using BeEF in a spear phishing scenario, obviously, for the same origin policy, this IP, which is mapped to this domain, is different. So you need to put here the domain name, in this case, if you're not playing with IP. So console log. So what is happening is the data that would be sent to the target is sent back to us. The junk is calculated, checking the headers. Then the stager is sent. The stage is sent as well, and then basically we should be able to use the IPEC shell. You can see obviously now in the console log of the victim, but everything is sent back to us, so we can monitor exactly what is happening. So like generating 150 knobs. In case there are errors for the port banning, all the process is stopped, obviously. And so you can, yeah. Now with the netstat here, you can see that there is a port 4444 listening. And now with the new console, very basic, I still need to improve it. So you just specify the target you want to connect to, which is actually a target where the shellcode is up and running, and you say exec netstat, and you can see the data that is coming back to BeEF in the logs, and you can see all the results, netstat, and then well, you can play with it. And for example, host name. Then you move to CD, and then, for example, we just want to create a file to show that it's not a bullshit, like from Ruby. So in this case, we just create a BeEF.txt in the C directory. There is also command history, pretty nice. And there is the BeEF.txt there, and there is also there, obviously. So yeah, unfortunately there is no time for the proper demo, but I can show it to you with beers later. So I guess it's all.
Yeah. I guess the only other thing that we didn't show was the Metasploit stuff. Can do that.
You want to? The module itself?
Yeah.
Yeah, right. This stuff. Yeah.
Yeah, so what's distributed? So I mentioned that I created a Metasploit payload module to add that into Backtrack. So we've got a instructions.txt file which has all this in it. Basically, you copy the 3 files, which is basically the stager, the stage, and the handler. There's not actually a handler, you just have to have a handler module associated for a payload module. So you copy those into those locations, and then you can basically just do things like it'll be available within the console, as well as to MSF payload. So if we just do these, it'll work in here.
Yeah.
So MSF payload might as well to list the payloads, grep the BeEF bind.
Yeah, it's running, it's a bit slow.
Yeah, I'll just put it,
Also Metasploit is low, honestly, by the way.
put it up so the guys at the back can see.
Also this computer is damn slow.
Yeah. Okay, so you can see in there that it's come back with the BeEF bind and BeEF shell.
Yeah,
And then you can basically start generating your payloads using it. So MSET payload, Windows, BeEF shell, BeEF bind. So it's got the S at the end, so it does a summary. You know, you can see what it does, the options for it. So you can see that it's got a dynamic option for the port. And then you can generate the different formats. So generate just a C format of the payloads. So if you scroll down a bit, so you can see the first stage up the top, so that's 299 bytes. It's got the L port, and then the stager, the stage, which is 777 bytes. So this has like nulls and things like that in it, so then you can use MSEF encode.
No, wait.
Oh. Okay. MSEF encode basically to specify bad chars, specify the null, and it'll basically generate it. You can see that in this case, so that'll generate the stager. And you can see it's now instead of 299, it's 326, and it's null free and all that sort of stuff.
Yeah.
And if you wanted to, you could specify the L port equals, 333, and it would set it up on that port instead.
Yeah. Any questions? No? Okay.
Any questions?
Thank you very much.
Thanks very much.